Hello, everyone. I'm Dr. Mazhar and I welcome you all to course Computational Intelligence and Probabilistic Reasoning. Today, I'm going to discuss the genetic algorithm with you. We discussed this algorithm briefly in previous lectures. So today I will try to discuss genetic algorithm in detail, and also I'll try to discuss the different variants of the genetic algorithm. So genetic algorithms are possibly the first algorithm models developed to simulate genetic systems. Uh, First proposed by Fraser and later by Bimmelman and Reed. But it was the extensive work done by Holland that popularized GAs. So it is then also due to his work that Holland is generally considered the father of GAs. GAs means the genetic algorithms. So GA is a short form of the genetic algorithms. So GAs or genetic algorithms model genetic evolution, so where the characteristics of individuals are expressed using genotypes. We discussed already the genotypes and phenotypes in the previous lecture. So if someone has missed that class, again he or she should go to watch that lecture and know about the genotypes and the phenotypes. However, the main driving operators of GA is selection. Selection means to model survival of the fittest, and the recombination through applications of crossover operator. Crossover operator, when we talk about crossover operator, means to model reproduction. So in selection and after selection, the parents are going for the crossover. So uh, in this lecture, we discuss GAs and their evolution operators organized uh, how. So we will discuss in a proper way and the details. So now we discussed algorithm, the initial algorithm of the evolutionary computing. Now, if you look at that algorithm which we discussed previously, that is a different which algorithm I'm going to discuss with you now. So this is called the canonical genetic algorithm. So if we talk about, because the canonical algorithm is proposed by the Holland, and this algorithm popularized the GA or genetic algorithm. So the canonical GA or CGA, as proposed by Holland, follows the general algorithm. Uh, जैसे हमने पहले भी डिस्कस किया था, what we discussed already in the previous lecture. So that works like that. However, in this algorithm, uh, mutation is a date that is not available in the evolutionary or the initial algorithm of evolutionary computing. So it's a like the means this is the canonical genetic algorithm or CGA. So if you look in the previous, it just it, so the bit string representation was used in the previous algorithm, and proportional selection was used to select the parents for a recombination or the crossover. And one point crossover was used as the primary method to produce offspring. In previous lecture, what we discussed these points, if you remember. However, the uniform mutation was proposed as a background operator of little importance. So it is valuable to note that a mutation was not considered as an important operator in the original G implementations. So uh, it was only in the later implementation that the explorative power of mutation was used to improve the search capabilities of genetic algorithms. So, since the CGA means the canonical genetic algorithms, the several variations of the GA have been developed that differ in the representation schemes, selection operator, crossover operator, and mutation operator. So, it is a valuable to note that mutations was not considered as an important operator in the original GA implementations. So it was only in the later implementations that the explorative power of mutation was used to improve the search capabilities of genetic algorithms. So since the CGA or canonical genetic algorithms, several variations of the GA have been developed that differ in representation schemes, selection operator, crossover operator, and mutation operator. So some implementations introduced other concepts from nature such as the mass extension or culling population islands, amongst others. We will discuss today all these things. So, while it is impossible to provide a complete review of these alternatives in this lecture, but we'll try to discuss the basic and significant things of these things. So this is the canonical GA. If you look at this, it looks same algorithm which we discussed in previous lecture. It looks like same. So it starts then the initialization and the means started the basically the initialization of the algorithm, and then the fitness is evaluated either this population is a fit or not, and then the parents are selected, and after the selection of the parents, process of the crossover is done, and after crossover mutation is done, and then if it's again fit, is what is the offspring. If it's a fit, then again it is added to the population, and that works again in this condition. Otherwise, and the algorithm is stopped, and it's the end of the algorithm. So canonical genetic algorithm means there are some the parameters that is, for example, the gene representation, how gene is a representation. So if you remember, we discussed that the gene means that if we talk about the computer systems, so gene is basically each bit of the binary string. What is the string? Is the chromosomes, for example. We discussed in previous lecture. So each bit is basically gene. Each binary bit or each bit available in the string is called the gene. And chromosome is the same binary string. Means the whole string. 0, 1, 1, 0, 0, and so on. And the whole string is a chromosome, and each bit of that string is called the gene. So, while the basically individual is a set of one or multiple chromosomes, because there may be multiple chromosomes in a single individual. So, it's a prospective solution to the given problem. What is the problem if you want to take some offspring? You definitely have the selection of the uh, parents from the population and perform all the processes of the crossover and the mutation. So, however, in this whole process, chromosomes performs a very significant role because without the proper or the fit chromosomes, no population may be extend or no offspring may come in being. So, since the population is a basically group of individuals, so if we start from here, this is the whole population. And population, what is population? Population is set or group of the individuals. Individuals are the sources to generate or to create the offspring. So definitely individuals, you may call them the parents. Individuals may be selected from the population, and they cross over, definitely during the crossover, chromosomes are used, and then the mutation occurs. So, in chromosomes, genes are available, which definitely used for the genotype and the phenotype. What is how genotype and the phenotype performs on basis of these genes which are available on the chromosomes, and the chromosomes are available in individuals. That may be human, that may be an animal. So definitely, a longer string length means this improves the resolution. If your chromosome is a proper and lengthy and proper and fit, then definitely this will improve the resolution. However, it requires more computation time. As I told you already, that this is not a fast process. Evolution is a slow process. If you look at the real world, you will find the process is very slow. So evolution is a basically slow process. However, when you if you apply this evolution process using the genetic algorithm on the computer systems, definitely need more computation time. Means it's not as fast as the other is a slow because it's in evolution. Do you remember that I told you that genetic algorithm give you not a single solution but a optimized solution. It has several solutions and finally it select the optimized fit solution. Optimized means that it's a fit solution that may work in a proper way, that solve your problem properly. So it give you the optimized solution means fit solution. So there is a population of the several solutions. So a genetic algorithm, what it does, it select the uh, proper and fit solution from the set of solutions and that give you. Therefore, it needs more computation time. So now this is the I think workers. So first of all, this algorithm means CGA evaluate the fitness. Means each individual X, for example, any individual that may be the X is assigned with the fitness value. F of X means function of X is the measure of performance. So it is assumed that the fitness value is the positive and the better the individual is the solution. The fitness value is more positive. If the fitness value is not positive, and for example, it's not fit or it's weak, then definitely it will not give you the solution. So it will not be the optimized solution. So if you need the optimized solution, so you have to evaluate the fit, what I say, the fit value means positive value. So when you select the solution, when you select the parents from the population that work for any job, so that should be the positive or the fitness should be fine. So objective function can be the fitness function itself if it is properly defined. After the fitness, means you have evaluated that this portion or this part of the population is a fit, then you have to select. So means the selection occurs. So in selection, what happens? Selection basically chooses the individuals from the current population. What is the available solutions? What are the available solutions? What is the available population? So individuals are selected from uh, those what I say populations to constitute a mating pool for reproduction. Means mating pool is that place where the crossover is done, and after crossover, definitely reproduction will be done. So fitness proportional selection methods is used that evaluate the fitness of these individuals. That either they are fit to reproduce the offspring or not. So each individual X is selected and copied in the mating pool with the probability proportional to fitness using by this function. For this purpose, roulette wheel selection is also this function or this procedure is used. We discussed in previous lecture. This function is as well. For example, if you look here, this is the individuals with the fitness values. Means this is the population. This is the population, and there is a different fitness values for each individual. So, definitely, what will you do? Definitely, you will select the fit parents or fit individuals that may reproduce the offspring. So, for the mating pool, you will select some fit individuals. So, means what happens, and this means assign a piece proportional to fitness value. Means select the individuals which are fit, and then this is the that we you commonly see this one. We run this. For example, you have a start here. So it stop at some point, and that will be either good or bad. So you select that, and definitely. So what is selected? That's the winner, and that will be go to the mating pool and perform the crossover. And after that, mutation will be occurred, and the offspring will come into being, and that will be again added to this population because they will perform again this process. So in a canonical genetic algorithm, so crossover, if you remember, we discussed already, this crossover also called the recombination. Crossover is basically the recombination of individuals, parents. So it is a genetic operator used to combine the genetic information of two parents to generate new offspring. So if you have studied the biology or the evolutionary system, the Darwin's theory, you may recall this function that how offspring come into being and how evolution is done. So there may be the single point crossover. For example, single point crossover is assumed here. Even the two parents individuals are selected from the mating pool, as I seen here. uh, so this is the mating pool, and these parents are selected from the general population. So crossover operation is executed with the probability, and crossover pointers are randomly chosen, and the strings are swapped with the respect the crossover point between the two parents. Means definite two parents means two chromosomes, one from father, one from mother. So two chromosomes uh, will be there. So their the genes what I say the strings these are one strings, this is a second string, so operators of the strings will be swapped. So there are different techniques. For example, single point crossover. So in single point crossover, what happens, it mark a line at a random point where you want to, for example, we have marked here the random point, this is the random point which is the marked here. So swipe the chromosomes of the crossed line to each other, like in offspring examples. So we have a crossed line here. So now these operators or points will not be crossed over. However, these will be crossed over with each other. So if you look here, these points are same. However, these are the crossover is now here 1 0 1 0. So 0 1 0 0 and 0 1 0 0. So 1 0 1 0. So this is a crossover, single point crossover. And another process of a crossover or method of the crossover is the what I call it the double point crossover. So now what happens in a double point crossover? Uh, it you should make lines at two random points. So like here, if you see the two random points, one and two random points. Left side will be this is the left side. Is the extreme. Uh, this is the extreme left, and right side will be the extreme right. So this is the extreme left. This is the uh, extreme right. So don't swipe the both extreme parts. Means these left and right parts will not be swiped. They remain will be same. how will swipe the middle part to each other. This is the middle part of each other. Is 1001. So 10 will be the 01 and 01 will be the 10. Even the uniform point, multi-point or uniform crossover may be done. In this, what happened? Generate the lines at three or more random points and perform the swiping of chromosomes in alternate parts of a string. So this is the crossover that is done for the in the mating pool. Then mutation occurs. Now this is the addition. This is the genetic algorithm that is developed by the Holland, and it is a different than the previous and original genetic algorithm. So mutation differentiate this genetic algorithm than the other, and this genetic algorithm is developed by the Holland. So what is a mutation? Mutation is basically a genetic operator used to maintain the genetic diversity. You see genetics, you see different genetic diversities in your family, in your communities, or in the world. Everyone want very intelligent offspring, Einstein, like, and so on. So definitely, this is the diversity, and some people think that we have to make relations with the non-blood families to uh, bring some diversities. So the yes, oh, okay, okay, okay. So what is his name? Okay, okay, I try something. So just finish me this. It maintains a genetic diversity from one generation of a population of a genetic algorithm chromosomes to the next. So mutation operator is applied gene-wise. That is, each gene undergoes mutation with the probability. So when the mutation operation occurs to a gene, uh, its gene value is flipped. For example, if it's a 1, it will be 0, and if it's a 0, then it will be 1. So like this, if you see, so if this is a 1, this will be 0, and if it is a 0, then it will be a 1. So this process occurs in the mutation. So definitely there are some techniques or schemes like the bit flip mutation. So flip the bit means modify the bit, like 0 to 1 or 1 to 0, or don't fill them, but keep in mind it will not be flipped 0 to 0. 0 to 0 will remain same. So if you look here, um, this is the office string 0 1 1 0 0 1. So mutation probability will be the 0 1, and again this 1 will be the 0, and 0 will be 0, 0 will be 0, and 1 will be 1. So muted office string will be 0 and 0 and 1 0 0 and 0. So, like if you look here, this is a 1 and 0. So, this is a mutation. In mutation, what happened? Bit is swapped with the opposite bit. This is the overview of the CGA total format, that how CGA, the genetic algorithm that is developed by the Holland works. So definitely initial population means initialize the population. What type of population you are going to set even in your system. Compare if you are going to develop uh, for any problem of your university, of your society, of anything, definitely you will select some population. If you want to work on the timetable, you will select the population. If you want to work on the sales and other problems, you will select the population. So, any means select the initialize the population, then perform the fitness evaluation, that how much population is a fit, and then select by using the selection process. And after selection, and what are the what items or what data you have selected, send it to the mating pool, and in the mating pool what will be done? the crossover will be done, and crossover after crossover mutation will be done, and what offspring or what result come, again it will be evaluated by its fitness, because these outputs or these offsprings will be added to the population. So this is the whole process of the CGA, canonical genetic algorithm. Now, if this is a summary of the CGA, so basically it presents the binary representations, fix the string length. String length means the chromosome, and fitness proportional selection operator. Evaluate the fitness and then select the individuals, and then the single point crossover operation is done, and gene wise mutation operator function method is also done. Now we discuss the genetic algorithm variants. This is also important. What are the variants of the genetic algorithm? So, based on the general genetic algorithm, different implementations of a GA can be obtained by using different combinations of selection, crossover, and mutation operator. Okay, so Wahid or Mustafa, may you allow the student जिसके लिए आप कह रहे हैं कि इसको आप ऐड करें, आप उनको ऐड कर सकते हैं, बिकॉज मैं तो पावर पॉइंट को फुल स्क्रीन कर दिया, तो आई डोंट वांट टू गो बैक एंड डोंट वांट टू ब्रेक दिस सेशन। तो आप अगर उसको कर सकते हैं, यहाँ जिसको ये हैं जो मुझे असिस्ट कर रहा है, तो वो उसको करे। So, based on the general GA, I was discussing the different implementations of GA can be obtained by using different combinations of selection, crossover, and mutation operators. Although different operator combinations result in a different behaviors, so the same algorithm follow जैसे as we discussed in the previous in the lecture, algorithm जो हमने discuss किया था, same ही उसमें है. So this is just ये जो portion है, a few G implementation that deviate from the flow given in the previous algorithm. So we discussed just that these three things: the generation gap method, message genetic algorithm, and island genetic algorithm. So, and the genetic gap method is basically generation gap is defined as the proportion of chromosomes in the population which are replaced in each generation. And in a genetic algorithm, Messi GAs means Messi genetic algorithm, process variable length, string that may be either under or over, specified with respect to the problem being solved. So, in contrast to the simple GA results, the Messi GA repeatedly solves the same problem to optimality and in islands. So we will discuss these our three types in detail. I just give you the brief introduction to these variants of the GA. So island model genetic algorithm is a multi-population based GA. It aims to avoid local optimum by maintaining population. Population means island. So population diversity using the migration. So generation gap method basically the GA is discussed thus far differ from biological models of evolution, and that population sizes because population sizes are fixed. So this allows the selection process to describe by two states. One is parent selection, and the second is a replacement strategy that decides if offspring will replace parents and which parents to replace. Because you see, when we reproduce the offspring, so in future offspring replace us. Means now our offspring will be the parents, and they will go for the same process what we done for them. यही होता है ना कि जो हम हैं पेरेंट्स हैं, हम जो एक प्रोसेस से गुजरते हैं, एवोल्यूशन प्रोसेस से, सेम जो हमारी औलाद होगी, अगेन ऑफस्प्रिंग जो हमारे होंगे, सेम वो ही आएंगे, एंड दे विल परफॉर्म द सेम व्हाट वी performed. So, two main classes of genetic algorithms are identified based on the replacement strategy used, namely generational genetic algorithms, means GGA, and steady state genetic algorithms, means SSGA, also referred to as incremental GAs. So, for GGAs, the replacement strategy replaces all parents with their offspring after all offspring have been created and mutate. So, this results in no overlap between the current population and the new population, means assuming that criticism is not used. So, for SSGA means STD, state genetic algorithm, a decision is made immediately after an offspring is created and mutate as to whether the parent or the offspring survives to the next generation. So there exists means thus there exists an overlap between the current and new populations. The amount of overlap, if you look at the amount of overlap between the current and new population, is referred to as the generation gap. Basically, generation gap है क्या? It is basically amount between the current and new population है. जो current population, for example, where and what will be our new population, जो इसके बीच में एक amount है, that is the generation gap. So, generation genetic algorithm or GGAs have a zero generation gap. जो हमारे SSG algorithms हैं, उनमें तो generation gap है, but जो GGAs have a zero generation gap, while SSGs generally have a large generation gap. So a number of replacement strategies have been developed for SSGs. क्योंकि GGA में तो कोई generation gap ही नहीं है, so we don't need any replacement strategy for the GGA. However, we need replacement. How we need the replacement strategy for uh, SSGA. So these are important. Focus on these things. That what are the replacement strategies and how they work. So a number of replacement strategies have been developed for the SSDs, like the replace worst. So where the offspring replaces the worst individuals of the current population. For example, our जो नई generation होगी, new population होगी, they will be added to the population, and they will replace the worst, means which are not able to reproduce more generation. So they will be replace them. However, replace a random is different because of what happened where the office in a replace random replacement, the offspring replaces the randomly selected individuals of the current population. Is some randomly. For example, you have evaluated the fitness. If their fitness is not fine, they will be replaced. Not like is in the first replacement, but in they will be replaced randomly. Not all are the maybe replaced. And another is a kill tournament. So, kill tournament where a group of individuals is randomly selected, means any group will be selected randomly, and then the first individuals of the group is replaced, means you have selected a random group, and then you will find the first individuals of this group, and those will be replaced with the offspring. Alternatively, a tournament size of 2 is used, and the first individual is replaced with the Probability means, for example, 0.5 is less than equal to p on the basis of their probability, and that should be less than a 1. Another is a replace oldest. And replace oldest means where first in, first out, EFO. First in, first out strategy is followed by replacing the oldest individual of the current population. So this strategy has a high probability of replacing one of the best individuals. And then the uh, conservative selection. So the conservative selection basically combines the first in, first out replacement strategy with the modified deterministic binary tournament selection. So a tournament size of two individuals is used, of which one is always the oldest individual of the current population. So the worst of the two is replaced by the offspring. Which are the worst? They will be the replaced by the offspring. Means offspring means the new generation. So this approach ensures that the oldest is the oldest individuals will not be lost if it is the fittest. So this is very interesting. Means if the in population some are the oldest, but they are fit. Means they are able to reproduce the generation, reproduce the offspring. They will not be replaced. But for example, some are young, but they are not able to reproduce the offspring. They will be replaced. Means those are the worst. So worst individuals will be replaced. For example, you have selected population of classrooms for your timetable or exam. What will you do? So you will replace those classes which are not fit to your exam class. Though that may be used for other purposes, but that class is not useful for your exam class. So that is the worst. So that will be replaced with other things. Then the parent offspring competition. So okay, the whereas selection strategies are used to decide if an offspring replaces one of its own person. They may definitely at some specific level, at some specific time, parents are not able to reproduce the generation, so after their offspring will replace them. So these are the generation gap methods and the replacement strategies that how they may be, how the individuals may be replaced. Means this is the survival of fittest. This is the survival of fittest. That those people are the useful for society, useful for anything which are fit. Even for you are developing any computer program, you have and you are using the genetic algorithm. What will you do? You will use the useful resources. It's same. Means it depend on you where you are applying this algorithm. And then the Messi genetic algorithm. This is also another variant of the genetic algorithm. So स्टैंडर्ड जो हमारे जेनेटिक एल्गोरिथम्स हैं दे यूज पॉपुलेशंस वेयर ऑल इंडिविजुअल्स आर ऑफ द सेम फिक्स्ड साइज so for example in x dimensional search space a standard GA finds a solution through application of the evolutionary operators to the uh, complete n of x dimensional individuals. So it may happen that good individuals are found, but some of the genes of good individuals are non-optimal. So non-optimal are not useful. So it may be difficult to find optimal uh, allele for such genes through applications of crossover and mutation on the entire individuals. So it may even happen that crossover loses optimized genes or groups of optimized genes. So in Messi genetic algorithm, individuals are of a variable length. not the fixed length, but they are of the variable length and is specified by a list of position value pairs. So the Massey basically क्या है कि Massey representation may result in individuals that are over specified or under specified. So the example of जो है इसका अगर हम illustrate करें, for example, the position specifies the gene index and the value specifies the allele for the that genes means what is gene to be message देता है. So these pairs are uh, if referred to as Messi genes. For example, जैसे ये है कि n of x, if you look here, is equal to 4, then the individual, तो इसमें 4 means there will be the 4 pairs. So there will be the 4 pairs. So like this pair is a 1, 0, 3, 1, 4, 0, 1, 1, represent the individuals 0 into 10. So they develop the what? Pairs. So अगर हम बात करें Goldberg ETL की, he has developed a message. Goldberg has developed a message genetic algorithm called the MGA, which finds solution by evolving optimal building blocks and combining building blocks. So here a building block refers to a group of genes. Means the building block are basically group of genes. So in the message genetic algorithm, individuals are of a variable length, not of the fixed length, and is specified by a list of position value pairs. So the position basically क्या करती है? Position specifies the gene index. Means the value specifies the allele for the gene. So these pairs are referred to as message genes. जैसे मैंने आपको इस example में I told you in this example. So is in this example, if you look, if nx जो मैंने आपको बताया is equal to 4, then the individual के ये जो pairs हैं represents the individuals. So the Massey representation, if you look here, the Massey representation may result in individuals that are over specified or under specified. So the example above means this example, if you look here, if this example illustrates both sizes. ये example में both sizes को illustrate कर रहा है. Means under specified and over specified. So the individual is over specified because gene 1 occurs twice. If you look here, this is a gene 1 and this is a gene 1. So this occurs 2 times. So gene 1 is uh, used 2 times. So this is a over specified. So it is a means अगर हम करें because so it is a under specified because gene 2 does not occur. और gene 2 की अगर हम बात करें तो वो under specified है because it is not specified or used. ये नहीं हुई है. So and has a no value assigned, even genes 2 का कोई value भी assign नहीं किया गया है. So fit sorry. तो जो फिटनेस वैल्यू है, सो फिटनेस या और द व्हाट इज द फिटनेस evolution of Messi individuals requires strategies to cope with such individuals. So for over specified individuals, a first come first served approach is followed, where the first specified value is assigned to the repeating gene. So now for under-specified individuals, a missing genes allele is obtained from a competitive template. So the competitive template is a locally optimal solution. As an example, if 1101 अगर ये binary आप note करें कि 1101 is the template, the fitness of 0 into 10 is evaluated as the fitness of 0101. So the objective of message genetic algorithms is to evolve optimal building blocks and to incrementally combine optimized building blocks to form an optimal solution. So an MGA or messy genetic algorithm is implemented using two loops as shown जैसे हम पहले algorithm में भी ये किया था. One is the inner loop consisted of three जो step हैं और एक outer loop है. These two हैं इसमें एक inner loop and second one is the outer loop. So the inner loop consists of three steps: initialization, uh, primordial, and just a positional. So the in initialization means to create a population of building blocks of a specified length. That is an of M. And in this portion, primordial, so which aims to generate a small promising building blocks and just a positional needs to combine the building blocks what you have specified, combine them. So in a loop, this process occurs. The outer loop specifies the size of building blocks to be considered. Means considered means starting with the smallest size of one and incrementally increasing the size until the maximum size is reached or an acceptable solution is found. Acceptable solution means the optimized solution is found. So the outer loop also sets the base solution obtained from the juxtaposition step as the competitive template for the next iteration. So if you look here, this is the message, what? Message genetic algorithm. So the initialization step, if you look here, creates all possible combinations of building blocks of length, means n of m for nx dimensional solution. So this results in a population size of this one. So this leads to one of the major disadvantages of message genetic algorithms and the computational complexity. What is the computational complexity that explodes with the increase in NM? You here it increases. So that is means the increase means the building block size that increases. So the fast message genetic algorithm addresses this problem by starting with the large building block size and adding a gene deletion operator to the primordial step to prune building blocks. So the primordial step is executed for a specified number of generations, applying only selection to find the best building blocks. So at regular intervals, the population is halved with the worst individuals. And worst individual means the building blocks in this algorithm means worst individuals discarded. So no crossover or mutation is used. While any selection operator can be used, fitness proportional selection is usually used because individuals in an message genetic algorithm may contain different sets of genes is specified by the building blocks. So there are different sets of genes. The thresholding selection has been proposed to apply selection to similar individuals. So the thresholding selection applies tournament selection, which we discussed we discussed tournament selection before this slide. So tournament selection basically were between the two individuals that have in a common number of genes greater than a specified threshold. So the effect achieved via the primordial step is that poor building blocks are eliminated while good building blocks survive to the juxtaposition state. Means if they are not able to produce produce the offspring, they will be discarded, and the working or the important, the useful building blocks or individuals will be selected. So the juxtaposition step applies basically where applies cut and slice operators. So the cut operator is applied to selected individuals at a probability proportional to the length of the individuals, that is the size of building block. So the objective of the cut operator is to reduce the size of building blocks by splitting the individual at a randomly selected gene. So the splicing operator combines two individuals to form a larger building block. Since the probability of cutting is proportional to length of the individual and the message genetic algorithm, so the message genetic algorithm starts with the small building blocks. Spacing occurs more in the beginning. Is अगर आप यहाँ देखें n of n में, so increases the cutting occurs more. So cutting and splicing then resembles the crossover. So this is the message algorithm. Another जो variant है genetic algorithm का, that is the I variant. So he lent themselves to parallel implementation. So three main categories of parallel genetic algorithm have been identified. One is a single population master slave genetic algorithms, where the evolution of fitness is distributed over several processors. Second one is a single population fine-grained genetic algorithms, where each individual is assigned to one processor, and each processor is assigned only one individual. So a small neighborhood is defined for each individual, and selection and reproductions are restricted to neighborhoods. So definitely this is the referred vitally refers to these as a cellular GAs. And the third one is a multi-population or islands. Now third one fits the island genetic algorithm. So multi-population or island GAs, where multiple populations are used, each on a separate processor. So information is exchanged among population via a migration policy. Although developed for parallel implementation, island genetic algorithms can be implemented on a single processor system even. So an integral part of island genetic algorithm is the migration policy, which governs the exchange of information between islands. So we look here, this is a migration policy. So a migration policy kya, that specifies means what is specifies a migration policy specifies, for example, इसमें different हमारे steps हैं. A community topology है. So a community topology which determines the migration paths between islands. For example, a ring topology, if you recall your course, data communication and networks, so recall the ring topology. So a ring topology allows, जैसे आप ये भी देखें, if you look here, this works figure, this figure, these are the islands and works and shape of the ring topology. So allows exchange of the information between neighbors island, means they allow each other to exchange the information between each other. So the communication topology determines how fast or slow good solutions determines to other subpopulation. So for sparsely connected structures such as the ring topology, islands are more isolated from one another, and the spread of information about good solution is slower. So sparse topologies also facilitate the appearance and multiple solutions. And densely connected structures have a faster spread of information, which may lead to premature convergence. And another migration policy, so migration that means the migration rate. So a migration rate which determines the frequency of migration. That how frequency kitni hai migration ki from one island to another island, one system to another system. What is the frequency of migration? So it determines the frequency of migration. Migration rate means to determine the frequency of migration. So tied with the migration rate is the question of when migration should occur. If migration occurs too early, the number of good building blocks in the migrants may be too small to have any influence at their destinations. Usually, migration occurs when each population has converged. So, after exchange of individuals, all populations are restarted. तो इसमें हम देखें अगर कि भाई एक सिलेक्शन मैकेनिज्म है सो a selection mechanism means to decide which individuals will migrate from one island to another island. For example, you do have several populations. So you will select which one should be migrate from population A to population B. Is आप देखें हम आपस में रिश्ते भी even करते हैं. What do we connect different populations and they available within their own community. So island means the different communities, different groups of data, different groups of resources. So a replace strategy क्या करती है basically? Replace strategy to decide which individual of the destination island will be replaced by the migrant. This is the function of replace strategy that which individual of destination island of or any island will be replaced by the migrant. So based on the selection and replacement strategies, islands genetic algorithms can be grounded into two classes of algorithms, namely static island one, static island genetic algorithm, and the dynamic island genetic algorithms. So for static, अगर हम static को देखें, तो for static island genetic algorithm, deterministic selection and replacement strategies are जो हैं followed by some examples. If you look here, a good migrant replaces a bad individual. For example, एक community में आप one community to community migration हो रही है और group to group हो रही है. So if someone is a good from community group A, it will may replace bad individuals from the group B. So a good migrant replaces a randomly selected individuals. That is another type. Even randomly कर सकते हैं replace a randomly selected migrant replaces a bad individual as well, or a randomly selected migrant replaces the randomly selected individuals. So select the good migrant. What are you doing? Select the good migrant means any of the fitness proportional selection operators given in जो हम पहले डिस्कस कर चुके हैं may be used. So for example, अगर हम कहें कि in every test strategy will have the best individual of the population move to another population. So Gordon uses tournament selection, considering only two randomly selected individuals. So best of the two will migrate, while the worst one will be replaced by the winning individual from the neighboring population. Another island genetic algorithm is a dynamic island genetic algorithms. So dynamic model do not use a topology, keep in mind. It does not use a topology to determine the migration path. Instead, migration decisions are made probabilistically. This on probability basis पे ये decision लेता है. So migration occurs at a specified probability. If migration from an island does occur, the destination island is also decided probabilistically. So tournament selection may be used based on the average fitness of the subpopulations. So additionally, an acceptance strategy can be used to decide if any immigrant should be accepted. So, for example, an immigrant is probabilistically accepted if its fitness is better than the average fitness of island. तो अनदर इंटरेस्टिंग जो एस्पेक्ट है जो मैं आपको बताऊं कि वो नो डाउट इसका एक पार्ट तो नहीं है लेक्चर का बट मीन एस्पेक्ट टू बी कंसीडर वो कंसीडर हो सकता है आइलैंड जीएस का दैट इज हाउ सब पॉपुलेशन should be initialized as we discussed in the dynamic and static सब population कैसे initialize की जाए. So of course the random approach can be used to initialize the subpopulation. Means a population within the population, if you want to generate, you should use the randomized random approach. So, which will cause different populations to share the same parts of the search space. So, a better approach would be to initialize the population to cover different parts of the search space, thereby covering a large search space and facilitating a kind of niching by individual events. Also, in multi-criteria optimization, each subpopulation can be allocated the task to optimize one criteria. So, meta level step is then required to combine the solutions from each island. So, a different kind of island genetic algorithm is the cooperative co-evolutionary genetic algorithm. हम उसको CCGA भी कहते हैं. So, in this case, instead of distributing entire individuals over several subpopulations, each subpopulation is given one or a few genes so, to optimize. So, subpopulations are mutually exclusive, each having the task of evolving a single or a limited set of genes. So, a subpopulation therefore optimizes one parameter or a limited number of parameters of the optimization problem. Thus, no single subpopulation has the necessary information to solve the problem itself. Rather, information of all the subpopulation must be combined to construct a solution. So, within the CCGA, a solution is constructed by adding CCGM is cooperative co-evolutionary genetic algorithm. So within the CCGA solution is constructed by the adding together the best individuals from each subpopulation. The main problem is how to determine the best individuals of a subpopulation, since individuals do not represent complete solutions. So a simple solution to this problem is to keep all other components, genes, within a complete solution to this problem. Basically, is to keep all other components. Components means genes within a complete chromosome fixed and to change just the gene that corresponds to the current subpopulation for which the best individuals is sought. So for each individual in the subpopulation, the value of the corresponding gene in the complete chromosome is replaced with that of the individual. So values of the other genes of the complete chromosomes are usually kept fixed at the previously determined base values. So this constructed complete chromosome is then a candidate solution to the optimization problem. So it has been shown that such a cooperative approach substantially improves the accuracy of solutions and the convergence speed compared to non-cooperative, non-co-evolutionary GAs. So, dear students, we discussed the different variants of the GA and the GA, canonical GA, that is developed by the what is the Holland. Hope you got it. So there's a little assignment which you have to done and send me before the next lecture, means next Sunday, coming Sunday. It's a very easy assignment. However, the previous assignment is not finished by you all. So definitely that will affect your examination mark. Uh, So focus your study, focus your assignments. This assignment is easy. Just what you have to do. You have to discuss the importance of crossover rate by considering the effect of different values in the range that is the 0, 1. We discussed in this lecture, even in the previous lecture as well. Another thing, compare the following replacement strategies for crossover operators that produce only one offspring. So the offspring always replaces the worst parent. These are the points. The offspring replaces the worst parent only when its fitness is better than the worst parent. The offspring always replaces the worst individuals in the populations. So this assignment is consisted of two portions. In first portion, you have to discuss the importance of crossover, considering the range 0, 1. And in the second portion or second part of assignment, you have compare the replacement strategies for crossover operators that produce only one offspring. Keep in mind that have to produce only one offspring following these 3 points. Hope you got it. If you do have any question, any confusion, you may ask. Or if you cannot ask now, even you may write in comments. I will reply you. Are you here? Are you hearing me? Okay. 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 Thank you. So thank you very much for hearing me, attending my online lecture. Thank you very much. We will meet in the next lecture. So thank you. Sabini na kaya. Means all have not done. Yes, but not all have done. Yes, some have sent me